Hey guys, this is the video for box and whisker plots. This is probably one that you haven't seen before. I really like it. Some people think it's a struggle. There are some special things about box and whisker plots. Remember on histograms, I can't tell what the mean is because I don't have actual values unless I'm given values. Most of the time, you're just going to get a histogram and you won't know how many people were surveyed. So if you don't know how many people were surveyed, you can't tell what the mean is. Okay. The median is the middle. You'll be able to tell that. And the mode is what happens most. If you don't have values and all you're given is a dot plot, a box and whisker plot, you won't be able to tell that as well. So it's something special about a box and whisker plot. All right, so let's look. Box plot is a diagram that is constructed using 5 values, also known as a box and whisker plot. Okay. And then an outlier, the first picture has an outlier, a value much higher or much lower than the other values in the set. So this dude over here is an outlier because most of the values are right here between 90 and 210. And then you've got this one way out here at 330. That's just crazy. If we had extended this line out here, it would appear that 25% of the data was stretched out over all this space, when in actuality, 25% of the data is right there in that tiny little chunk between 200 and 210. So looking at the process on how it works, here's some keys to keep in mind while you're doing it. It says make sure you put your numbers in order from least to greatest, which you are used to. Have a little bit of coffee here. You want to draw and label your number line. Most of the time, you're going to get a number line. Just be careful when you're looking at number lines on given work, okay? Don't forget to give your number line a title. So this one has the title of car speeds. And so Miss Bridges went in and put lower extreme is 19. So that's our min. Upper extreme is 40. So that's our max. So I can still find the range. And then the median here is 25. See how she found those things over here by circling stuff, okay? She also found Q1 and Q2, okay? Q1 and Q3. So the median, so I can find the middle, and I can find Q1 and Q3. So I could also find the IQR. Agreed? All right. Be sure to write as you go and pause anytime you need to. So this one represents a data in a box plot. It's the depth of recent earthquake in kilometers. So this is how deep into the earth these earthquakes are going. And you can see how many we have. So I could find mode and mean for this one, but lots of times they're not going to give you a table. Although on a star question, I did see this. They give you a set of data and your answer choices. One is a box and whisker, one's a histogram, one's a stem and leaf. They'll give you 4 different types of graphs and ask you which one represents the data. So it can get pretty tricky. So as you can see, they're ordered from least to greatest. There's my median. There's my Q1. There's my Q3. Okay, so we've got our max, our min, our median, Q1 and Q3. I have to hide that because if I hit hide, the video will end. And so there it is on the thing. Oops. It says 1, we're going to find the upper and lower, our max and our min. And 2, we find the median. And then, of course, step 3 is to find Q1 and Q3. On this one, it's another one of those where we have to interpret the data. It says students recorded the amount of liquid in fluid ounces each of them drank in one day. The box plot shows the summary of the results. So let's look at this. Do we have any data set numbers? No. Do we have any idea how many students are represented here? No. It could be 20. It could be the whole school. We have no idea. Do we know if any of them are boys and girls? Nope. Have no idea. So we're going to decide which statement is true. So let's look. Let me move that. So we're looking at fluid ounces, recorded amount. We want the best describer of this data. So let's see. Half of the students drank from 78 to 114 fluid ounces. Well, we're going to say that that's about 78, even though it's not marked real well, but we know 78 is between 72 and 84. And this is probably 114 because it's between 108 and 120. And that is 50%. So I'm going to say that that's the right answer. Let's prove the other three wrong. The greatest number of students drank from 30 to 78. Well, 30 down here up to 78 is half the students. So we know that's not a greater number of students because that's half of them. H says the data represents 78 student responses. Does it say up here 78 student responses? Nope, there's no way to tell. And then the last one says the mean number of fluid ounces the students drank is 78. We can't tell what the mean is because mean is what? The average. We add and divide. We don't even know how many responses there were. So we have no real way to tell. Remember to write as you go. Pause the video as many times as you need to. All right, let's look at this one. This one is a lot of times you're going to see a double box and whisker on an exam. So we're going to compare the median numbers of students in homeroom for each grade. We're going to compare the range of students of homerooms for each grade, compare the middle 50% of homerooms for each grade, and interpret the data, the double box plot. So what they're asking you to do is say what these answers could look like for this box plot, okay? So let's look at it. So compare the median is the middle, number of students in a homeroom for each grade. The median of 7th grade is 5 more than the 6th grade. This says 7th grade has 5 more students than 6th grade. On average, 5 more students in 6th grade in each class. So that doesn't mean that every single class has 5 more students. It's just saying on average, there's more kids in the 7th grade classes by around 5. So B says, compare the range of students in a homeroom for each grade. The range for 6th grade and 7th grade is 14. They're exactly the same. Okay, so the max number of students in the 6th and 7th grade and the min number of students in the 6th and 7th grade is 14 apart. B says compare the middle 50% of homeroom in each class. Well, the middle 50% is what? It's my IQR. My IQR in a box and whisker plot is in the box. The box is the IQR. Oops, it went too far. I touched it. So the middle 50% for 7th grade is 4, while the middle 50% of 6th grade is 6. Also notice that the 7th grade IQR, or middle 50%, is very evenly distributed, whereas the 6th grade is kind of worky. It's got this little bitty over here, which means a lot of classes have 18 to 19 students, and not as many classes have 19 to 24, because if this is 4 classes, this is 4 classes, okay? So it's spread out more. So D says interpret the double box plot. 7th grade's box plot is pretty symmetrical. So 7th grade is relatively symmetrical. It's got one section that's a little bit longer. Symmetric means that all these are about the same to 6th grade. In general, 7th grade has more students in 6th grade. Because look at 6th grade. It's nowhere close to symmetric. We got tiny, tiny, giant, giant. Okay? You can pause the video to write that stuff down. Make sure your notes are filled out. All right. The box plot shows the weight in ounces of 15 different bags of almonds. About how many bags contain less than 27 ounces? So here's 27 ounces, right? And so you're going to decide how many of the bags out of 15 do you think are over here? So this is half of the bags. Hint, hint. Try that one on your own.